Okay, 3.2 radians and degrees. So far we've worked in degrees, and the only thing you know about radians is if your calculator's in radians, you get the wrong answer, correct? So now we need to figure out what a radian is. Okay, a radian is the radius, so this is my radius, right? Marked on the circumference of the circle. So if I took a piece of string and measured this radius and then laid it on the circumference of the circle, that is 1 radian. So are there more radians in a degree or more degrees in a radian?
More degrees.
More degrees in a radian, because a degree is much smaller than a radian. What's kind of fun about a radian is the circle on this pin cap right here on this end and the circle on this end, and any circle you can find has approximately 6.28 radians in every circle, no matter what size the circle is. What would be special about 6.28?
3.14.
It's twice 3.14. Okay, so you guys have your circles, right? You had your circles, and you had an extra line on your circles, and it said 0 degrees, and we had this extra line, right? Guess what? That's how many radian? 0. Do you want to open to your circles? And this was 180 degrees. And we just talked about 6.28 was so 0 degrees is 0 radians. Okay, so I said there's 6.28. Don't write 6.28, but there's 6.28 in one full revolution. Well, what's half of 6.28? Which is what? Pi. So there's pi radian here. So I got 0 radian, pi. So when you think pi, you think 180. So I go all the way around and I get 2 pi. Now, this is why a degree symbol on your angles is so important, because if there is no degree, I'm assuming it's a radian. And we already talked about the radian is a lot larger than a degree. Okay? So, if we have 0, we have pi, then what's 90?
1/2 pi.
Okay, or pi over 2. So I have 1/2 pi, 2/2 pi, and then 270 would be what?
3/2.
3/2. So 3 pi over 2. Okay. There is a formula to convert from degrees to radians, but these angles, we're going to use it that they're a fraction of the circle. Does that make sense? We're going to use a fraction math. I didn't get all of it in there anyway. Sorry. Okay, so 30. How many times does 30 go into 180? 6. So that would mean there's 6 pieces of 30-degree pi in pi. So it's pi over 6. We're going to keep with the 30s. So remember when we talked about like subtracting from 180, adding from 180, that kind of thing? So we're going to do the same thing. If I'm 1 less than a whole piece of pie and there's 6 pieces, how many pieces do I have? 5. So this is 5 pi over 6. Then I'm going to go to 210, which is my 30 in the third quadrant. So I'm not 1 less now, I'm 1 what? More, so it's 7 pi over 6. So what's my 30 in the fourth quadrant?
8 pi.
Well, what degree is my 30 in the
330.
330? Okay, so I'm 1 less than 2 whole pieces, and there's 6 total. So what's less than 2 whole? There's 6 pieces.
11.
What?
11.
11. Okay, so why did we put 6 in the denominator?
Because there was 6 and 1 4.
There, 30 goes into 180
6 and
6 times. Then when we are in the second quadrant, we're 1 less than a whole. Third quadrant, we're 1 more than a whole. And when I'm saying a whole, I'm talking a whole pi. And then the fourth quadrant, I'm 1 less than 2 whole. So if there's 6 pieces, 2 would be 12. Make sense how that works? Okay, so let's go 45 then. How many times does 45 go into 180?
Like 4.
4. So we have pi over 4. Of 1/4 of pi. So what's my 45 in the second quadrant?
135.
135. So I'm 1 less than a whole, so it's
3 pi over 4.
3 pi over 4. 45 in the third, 225. So this time I'm 1 what? 1 more, so it's 5 pi over 4. And in the fourth quadrant,
7 pi.
7 pi over 4 at what degree?
315.
315. You guys want to try 60 on your own?
Sure.
Okay. Okay. Who wants to take a stab at 60?
5 over 3.
Pi over 3. Why, Emma?
60 goes into 180 3 times.
Okay. Not Emma for second quadrant.
2 pi over 3.
Why 2 pi over 3, Cayenne?
Because it's 1 before.
1 before pi.
Yeah.
Okay.
4 pi over 3.
Why?
Because it's 1 over a whole.
1 more than a whole. Either one of you two.
You got it, bud.
Fourth quadrant.
Where?
Put 300. We got 3 pieces, and we're 1 step to get to 2 pi. Three times 2 minus 1. Yep, 5 pi over 3. Okay, The fourth quadrant is the quadrant people struggle with the most. Can anybody guess which one of the three make you question the world? 11 pi over 6 is the one that seems to give people a hard time. Fourth quadrant, guys, times the denominator by 2 and subtract 1. You're 1 less than 2 whole pi.
Why? Like why?
Why? Because we were coming around 360 is 2 pi. So with and so we're 1 step away from getting there. So if there's 30 went into 186 times. So if I'm doing that, 12 pi over 6 would give me 2 pi. So 1 less than that would be 11. Okay, and then 7 pi over 4, 8 pi over 4 would give me 2 pi. So 7 pi over 4. Does that make sense now? Okay, Olive?
No, the other one I didn't get.
But does it make sense now?
Yeah.
Okay. So if you're struggling, you multiply by 2 and subtract 1. Okay? So first quadrant, you divided 180 by the angle, correct? Then second quadrant, we were 1 less than pi. Third, we were 1 more than pi. And then the fourth quadrant, we were 1 less than how many? 2 pi. There's this whole thing there's a symbol called tau. It looks like half a pi. See that? See this? It's tau. And they really tried to change a whole rotation to be pi. And then 180 would be tau. Because 2 pi is counterintuitive, evidently. I don't know. There's this girl that does a whole YouTube thing on it, and it's kind of fun to watch her do it, but I'm like, oh gosh, that's a lot of mess. So now you have everything filled out on the circle. When you hear after today, the next couple days, when you hear pi over 6, you should think 30. When you see 30, you should think pi over 6. In your brain, you can convert them back and forth. On paper, you will not be after today. If it asks you for the sign of pi over 6, you are telling me 1/2. You're not writing it the sign of 30 equals 1/2. Does that make sense? Okay. You've got to just start thinking that way. Okay, so we know what a radian is. Conversion. Okay, so let's talk about the conversion to it. So when we had this, right? Half of our pi was, half of our circle is pi. A whole rotation is 2 pi.
Yeah.
Okay? So 2 pi equals 360. So when we divide by 2, because we don't want 2 in there, right? So pi equaled 180. So that actually gives us our conversion factor. So from degrees to radians, I will write degree under here first to this time, and then after that I'll just put T to R. Okay, if I'm going to go from degrees to radians, I'm going to multiply by pi over 180 degrees. That's my conversion factor. If I'm going from radians to degrees, I'm going to multiply by its reciprocal. So 180 over pi. Now we need to stop and think about it. Not all radian measure have a pi in it. They could have...
Can I take this really quick?
In the hallway. Not all radian have a pi in them that you can see, but there is a pi that could be mathematically worked out. Does that make sense?
Yeah.
So if you think about it, if I want to put it into radians, I'm going to multiply. I'm going to have the pi there. I'm going to reduce out the degree. If I want to put it into degree, I'm going to have on the numerator? The degree. So, convert 450 radian. 450 degrees to radian. So 450 degrees times what? Which one am I going to use? I'm converting to radian.
Oh, the top one.
So pi over 180 degrees. Now, from science, guys, when you do conversions, you want your units to be one in the numerator, one in the denominator, yes? Do I have degree in the numerator and degree in the denominator? Yes. That's how that, okay? So I'm assuming we cross out, we do that. What goes into 45 and 18? 9. So I get 5 pi over 2. So the nice thing about radians, I immediately know this is a quadrantal angle because the denominator is 2. If the denominator is 6, I immediately know the reference angle is 30 because it always will be. 30 goes in 180 6 times. 90 goes into 180 what? Twice. Make sense? Mm-hmm. So I know this angle right now is a quadrantal angle because it ends in a 2. And they will say graph or draw or whatever it says. So we need to figure out where it's at. So 2 goes into 5 how many times? Twice. With 1 left over, right? Mm-hmm. So that would be 4 pi over 2 plus pi over 2. Would that not be 5 pi over 2? 4 pi over 2 plus 1. Yes? So that means I go all the way around plus 1 more pi over 2. And that is 5 pi over 2. Okay, 20 degrees to radians. So 20 times what? Pi over 180. So you get pi over what?
9.
Pi over 9. So this is 20 degrees, right? But I want to show you what 20 radians looks like. Okay, well, 20 radians, how many were approximately in a circle?
16.48.
Okay, 6.28. So how many rotations is that? How many times is 6 going to 20? It's 3, right? 3 complete rotations. So 1, 2, 3. We're not over half. We're like here, right? And this is 20 radians. And you'll see an R behind them sometimes, but I just don't put anything. If you don't put a degree, my assumption is it is at a radian. So is it important to put your degree symbol? Big time. Because a degree actually shows movement, correct? And 20 degrees is very little movement. 20 radians is what? A lot of movement.
It looks like a target.
It does. Okay, anything that ends with a 3, a 6, a 4, a 2, try to do without doing a whole process. But today I would understand if you were doing a whole process just because it's the first
A
time.
2 is just like 0, 360.
Yeah, 2 is quadrantal angles, yes. Okay, so they got pi over 6. What's pi over 6?
30.
30. So if you get like pi over 6, what I mean by do it without the whole process, you just say, ask yourself, how many times does 30 go in, or how many times does 6 go into 1/8? And you say 30, right? So what if I had 5 pi over 6? Still talking what? 30. But what quadrant am I in?
1, 2.
Second.
Second. So we do 180 minus 30. So 150, and that's what you were doing in your head, right? Okay. So still work on those exact values because those you have to know. That's on that big table. You get that soon. This week or next week. Okay, I'm going to hand it out to you and we're going to fill one out. Because now we have everything on there. Okay. 4 pi over 3 to degrees. So what am I going to multiply it by? 180 over pi, because I want to reduce my... Now, does every radian have a pi that you can see in it? No, because I just did 20 radian, didn't I? Okay, so the pi's reduce. What else you want to do? I don't want to multiply 180 times 4. What do you want to do?
Reduce the 180 and 3.
180 and 3 to 60. So we get 240. But again, there was 3 here, yes? If there was a 3 in the denominator, we know our reference angle is what? 60. Why? Because 60 goes in 180 how many times? 3. And 4 means it's in what quadrant? Third. So it'd be 180 plus 60, which would be...
I just did it like that. Is that okay?
Yes, like what we just did? Or this?
No.
Like what we just did? Yes, that's perfect. I did it this way just to do it, but if you get a 2, a 3, a 4, or 6, please do it the way we just did it with the reference angle, okay? Because it will help you remember them. Negative 4.5 to what? What is that? Radian or degree?
Radian
Why?
doesn't have a degree.
It doesn't have a degree. So I'm converting it to degrees. How do I convert negative 4.5 to degrees?
No, 180.
180 over pi. Put whatever you want in the numerator. Okay. Without a calculator, because I do things like that, you would leave it with a pi in it, correct? And we got to multiply that. So 450. And then 80 would be 0, 4, 2, C, 3. So 0, 1, 8.
No.
Don't pay any attention to me. I multiplied by the same number twice. No, that was right. You guys multiplying because my brain is, I can't say out loud what I'm doing because my brain is not going to do it.
40.
I get 81. That doesn't seem right. Oh, but it's 4.5, that's why. Okay. So without a calculator, you would do that. With a calculator, you use the pi button. You all know there's a pi button on your calculator. Yes? Use it. Do not use 3.14 ever. One last thing for you before I let you go on your assignment. Okay. Simplify the third directions. Pi minus pi over 3. So what's it telling me to do? Simplify. So you have to do what? Like, how am I going to do that?
Multiply values. I don't know.
I have pi minus pi over 3.
Use
One minus 1/3.
It's 3 pi over 3 minus pi over.
It's 3 pi over 3 minus pi over 3. So it is what? Just fractions, guys. Just fractions. So like 41 through whatever, it says draw the angle in standard position, convert to degrees, and label your reference angle in both degrees and radians. Do we need to do one of those together?
What's standard?
Yeah, sure.
What'd you say, Emma?
What's standard position?
What's standard position? Anyone? It's just on your last assignment.
That just one circle.
Positive x-axis is your beginning. Okay, I gave you all odds, right? So,
It's all things.
not evens, sorry. So negative 7 pi over 6. So we're supposed to draw it, we're supposed to convert it, and we're supposed to give it. Okay, I'm going to tell you I do my reference angle first. Just because. Remember theta with the party hat?
Yeah.
Okay, in radians, your reference angle is right there. When we did our circle, did we not just do the numerator, one more, one less?
Yeah.
So what is my reference angle? Well,
Pi over
radians and degrees. So pi over 6, which is, Emma,
30 degrees.
30 degrees. So that was C. That was reference angle in both radians and degrees. Okay, so negative, so that means we're going this way, yes, backwards. And it's, this would be negative pi. So 7 pi over 6 would be in what quadrant?
first.
Wouldn't it just be in the second? Because
Yes.
it's one more than a whole?
Third.
I mean, no, second, negative.
Oh, my bad.
It's negative. So it's one more than a whole. So it'd be in the second quadrant.
Yeah, it's real backwards. Don't yell at me, Miss Man. Not cool.
You shocked me. You shocked me. Okay. So that's A. And then B was convert. So we're going to do it without doing the formula, right? Because it's the denominator is what?
6
6. So our reference angle was what?
Third quadrant, which is,
30, but not the third because we're going backwards.
oh, second,
So it's 180 plus, so theta equals 180 plus 30, which would be
210.
210.
That's what I said.
Okay. I was just spelling it out. I'm going to stop spelling it out really soon, so take advantage of me spelling it out. So that was, we didn't do A first, we did what?
C.
C. Did C help us do A?
Yes.
Yes.
No.
And then it says use the calculator to convert, so you'll just put the conversion in your calculator. You'll just put negative 4.5 parentheses 180 divided by pi. That's it. And oh, find exact values. Well, sine of 4 pi over 3. Okay. So my reference angle is what?
60.
Okay. In my brain, I'm saying 60. Yes? What quadrant am I in? Third. So is sine positive or negative there?
Negative.
Negative. So I've negative the sine of pi over 3. That's 60. And the sine of pi over 3, which in our brain we're going 60, is negative because it's negative. And what over what? What's opposite 60?
Square root of 3.
So square root of 3 over 2.
Forgot how to draw a square root for a second.
Your brain just exit the building. So if it's an exact value, it's going to be an angle you should know. Yes? Okay. Today, if you need to write theta hat equals 60 down on your paper so you can see it, do it. But then we need to get away from doing that. Our brain just needs to. Got it? Okay.